I'm here to talk today about railway-oriented programming and how it helps us get back on track. Before we get on track, we need to get off track. People ask me, how long does it take to make a talk? This talk is about 20 minutes long, and I'll run through what I went through to create this talk. I used Claude AI to generate me this diagram using a language called Mermaid. It's a great diagramming tool, really clean syntax and so on, and it creates this nice, pretty diagram of railway-oriented programming that I'm going to show a little bit later on. However, when I went to put this diagram into my slide template, it didn't work because the background, it's not transparent. So I thought I could ask my friend Google just to share the love around, you know, one query to Claude, one query to Google, one query to ChatGPT. No one then gets the market share. And I asked Google, Mermaid transparent background. And you know what Google did? It delivered. So I thought I could just brew install Mermaid. No such thing. You can't just do brew install Mermaid. You need to install Mermaid CLI. And so the way that you do that is you do brew install Mermaid CLI, and then you try and run the Mermaid command, but it's not called Mermaid, it's called MMDC. So you give it an input path and you give it an output path. Unfortunately, you don't have to tell it what kind of output you want. It just knows based on the file extension. We're living in the future here. It's incredible stuff. But you can't find the right version of Chrome. Why does it need Chrome to generate a diagram? It's because Chrome that I've got installed on my machine is at Chrome 139, where it needs 131 instead. So I run brew uninstall Mermaid CLI. I actually expected this command to tell me, you don't mean to run uninstall, you mean to run remove instead. But no, it actually worked. Then I installed npm, I did npm install -g and then the Mermaid package, and I got unsupported Node version. This is because depending on how cursed my day is, I'm using any version of Node from 10 up to 22. So I switch up to Node 22 and I run it again, and finally this time it works. Sensing a pattern here. I run mmdc-i mermaid and I try and do the output of the file. I get back a diagram. I try and put it in my slides. It doesn't work. I'm questioning my choices at this point. I run it with -b transparent, which is the option you need in order to have a transparent background. It looks shit. I run it with a -t option, which allows you to provide a theme for when you're embedding it into dark themed places. It looks okay, but doesn't look good. At this point, after about 2 hours, I cut my losses and go back to the original diagram. So it takes me about 2 hours of fiddling around with these tools before I can start working on a talk. I need to know what I'm doing before I actually do it. Then it takes me about 10 to 20 hours of getting together slides and ideas and actually making a cohesive narrative. Some of that time is also spent laughing at my own jokes because I'm a sicko. The whole reason we want a cohesive narrative is because we love flow. We love beginning, a middle, and an end. We love the hero's journey. We're suckers for that stuff. We want the beginning, who is our hero? What's the middle? Oh, what challenge are they up against? And then they finally vanquish evil and that sort of thing. And by God, do we love a bit of meta storytelling. Railway-oriented programming, let's get back to it, is a way of programming so that you have two tracks your code goes down, either the happy path or the sad path. In this case, we have a merchant authenticating, and you don't need to care about what specifically they're doing because I reckon the people in the back row probably can't read that. The point is here, the merchant is either found or not, they're either active or not, and the password is right or wrong. So we want to check those things. We want to see if the merchant exists, if the password is correct, and if they're active. And if any of those steps fail, we go over to the right side of our diagram, over to the failure case. Yes, this is a graph of an if statement. Bear with me. Some of the railway-oriented programming will helpfully refer to this stuff as the left and right paths, which I've clearly labeled here. I prefer either success or failure, or happy or sad, depending on how whimsical I'm feeling. And I always feel whimsical. When your grandparents were still in high school, there was such a thing called the Rails way. It gave an emphasis on skinny models and fat controllers. Back then, they would write code like this, throwing as much business logic as possible into the controller. You'd find the merchant, you'd determine if they're active and if the token is correct, and then you'd render some JSON based on the output of that. This looked a bit messy, and so you would find a nice dumping ground in the model. It doesn't belong in the controller, it doesn't belong in the view, it doesn't belong in the helper. Rails provides nowhere else, guess it's the model. So you chuck it in there somewhere around about line 100. You add the function, you add that functionality because the models aren't overloaded already enough. Some Russian hacker attempts to claim a bug bounty against this particular piece of code, despite your company not having a bug bounty. You find a blog post that suggests using secure compare, and you make that a critical part of your authentication process, and you stake your company's success on this feature, hoping Rails never removes it. After adding merchant authenticate, you can now simplify your controller, and you do so by calling merchant authenticate and then checking if the merchant is active, and so on and so forth. You then read a book by a young upstart called Sandy Metz and end up refactoring this code to use unless and early returns. This improves the legibility of this code, and you can now read it like a 3-course meal rather than some kind of sick code mukbang. You might think it ends there. If things go well, all the steps flow down the left side of this chart, and if any step fails, we switch over to the tracks of the failure side, and we do not perform any steps past the one that failed. It doesn't end there though. We can tidy up this code further by moving it into a different directory of our app, which is app operations, and making an operation class within that directory. I call these operations because the name makes more sense to me than transactions and services. Another benefit is that I can spell operations first time each time, and transactions I mistype, despite working at a payment processor. I loathe to use the word services here because this is Ruby and not Java, and I code in a t-shirt, not a suit and tie. The operation code uses dry monads and its result feature. The result feature of dry monads gives us a failure and success methods, which we can use to indicate the outcome of this operation, which radically tidies up our code. In the controller, you can use case within, which is the Ruby pattern matching feature they added in 3.0, and match the success and failure outcome for this operation. This further reduces the code with the controller, within the controller, to something that only cares about calling out to another class and responding based on the outcome of whatever that class is doing. If you want, the operation can now be used in other contexts of your application without copying and pasting this logic everywhere. If you wanted to use it outside of your controller, it is now possible. This shift has one big win. You can test the authentication logic without also having to cover what the controller is doing. Admittedly, this current example is a little contrived because this is how all talks start out. A simple example to lure you in, and then they hit you with a multi-thousand line example later on. Another win, but a smaller one, means that the code that was in our model now has a better home, which it now belongs in this operation class instead. The model, which was already overloaded with responsibilities, now has one fewer responsibility. It doesn't know about authentication, and the controller doesn't know about it either. It's not split up between the controller and the model. It's now all centralized into this one simple class. I have a very strong opinion that models in Rails applications should only know how to represent data and have methods to deal with that data. Models should not know about the business logic of your applications. It is what operations are for, and they are a big missing piece of Rails. You'll note here as well, in these failure cases, I'm using strings, and you could return those as error messages back to the users if you want, or you can switch over to using symbols, and that can indicate the type of failure, which you can then pattern match in your controller like this. Or you can simplify it and just have one to match all failure cases and maybe log the reason that you want. Again, it means only the controller knows about how to send its parameters over to the operation and not over to the model and handling any authentication logic itself. It's all tied up in that operation class instead. Now, I said this example was contrived, and it really is contrived. And I warned you that I was about to bring out a bigger example and gave you ample time to leave the room and run away. But you're still here. So here we go. I work at Fat Zebra, a company that processes payments. We process about 1 in every 5 Australian payment. One thing we let our merchants do is authenticate, and the other more important thing that we let them do is transact with credit cards. You know how you're not supposed to handle credit card data in your applications? It's because we do that for you. When someone makes a purchase, it goes through the merchant authentication code, and then it hits this 464-line controller action, which I've left the code out here for your sanity and mine. It builds up the purchaser's data and decides if it wants to proceed with the act of making a purchase. The act of making a purchase starts in this 267-line method in the purchase model. The purchase model's transact method now runs some more validations and other checks before deciding to send the payload to this 360-line method in a separate application. Why another application? Because microservices were the hotness at the time. And in the true nature of all microservices, this has become a macro service of a little over 30,000 lines of code, excluding tests, which account for another 70,000 lines of code. The code in this purchase method now works with the payload, converting it into banklang and eventually sending it out into the world. All the methods before this that I've mentioned then handle the response from the banks in their different ways. The method in this second app includes such hits as this, which is clear and you can easily understand that. But when I look at this, I get flashbacks to this advent of code puzzle from 2023, when you have different nodes that are all connected and you have to find the one in the middle that disconnects the two halves. Once the message goes out, it usually goes out to a company like Fiserv, who handles this payload in very mysterious ways with a small group of 38,000 employees. Now, I use this exceedingly large example to demonstrate one thing, that railway-oriented programming isn't just for small examples at the start of talks. It is also for the ones in the middle of them as well. Taking the 10,000-foot view of this code isn't enough. We need to go much higher than that. So we catch a rocket up to the International Space Station and look out the window, and we can see this code is doing 6 major things. It is trying to validate input, it tries to find a card by a token if it's provided, and then it does a couple of fraudy checks. Is the card blocked by the network? Does the merchant allow processing in that country? And has any of our fraud systems alerted us that this transaction is possibly fraudulent? If any of those steps between 1 and 5 fail, we can bail out there and then. Only at step 6 do we ever send it to the bank. If we chart this out, thanks to Claude again, I went back to Claude, we get this thing that looks like an octopus with a limp. At any point of the purchase process, we can bail out early and not run any further checks, which saves us processing time. We could approach this by refactoring out the whole lot to use the do feature of dry monads. The do part of dry monads allows us to split our code up into smaller methods, each which returns either a success or a failure. When the yield happens here and it sees a failure, it will stop in its tracks and return that immediately out of this method. It bails immediately. No if statements, no else, just yield. If we get right to the end, we will return a purchase object wrapped in success. Now you might think, Ryan, you've been at this for a very long time, surely. You've been at FatZebra now 4 years. The purchase code that you showed before doesn't actually look like that. It looks like this instead. No, it doesn't. Doesn't at all. It's what I wish our code looked like. And given that this is so central to what FatZebra does, any single one mistake in here would be grounds for immediate dismissal. So developers are rightfully afraid to touch this code in very dramatic and ground-shaking ways. I use this example to demonstrate 2 major things. We're not perfect, and even a big blob of code like I showed, something nearly 2,000 lines long, could be refactored down into this simpler example. And you've probably got something like this within your own application, something really gnarly that could benefit by applying what I've talked about here today to make it easier for the developers, you and your friends, in the future. My suggestion with your code and our code as well is to build smaller operations first. Start tackling only a part of it at a time. I would pull out the find by token stuff first, for example. And then later on, piece it together into a larger operation over time. So I'd split out FatZebra's one by splitting it out into those 6 steps into their own operations and issuing smaller pull requests one by one. You'll find places like this in your application where your code is confusingly mixing things together. Maybe you've got some complex code during the sign up for your application, like this example. This code is confused about what it does. Is it business logic? Is it interacting with models or mailers? Is it handling controller responses? The answer to all of those questions is yes, it's doing all of those things. We can move out a lot of this business logic into its own operation, splitting each step up into its own method. Now, if you think the yield syntax looks a bit weird, I agree with you, and the dry-RB maintainers also agree with you. They've released a gem to handle this called dry operation. You simply inherit from dry operation, and you can then define your steps just as steps. And instead of yield, we now have step. We still have access to the monad stuff of success and failure, and each step will return either success or failure, and it will bail out early if it needs to. It also comes with an active record extension, which allows us to wrap our operation into a transaction block to roll back database operations if any one of those steps fail. And we can also subscribe to failures for these operations, perhaps logging out when things go wrong. I encourage you to check it out. I bring up dry operation and railway-oriented programming today because would you prefer to look at code like this or code like this? You'll find places like this in your applications where code is confusingly mixing things together. Maybe you've got some complex code during the sign up for your app, or maybe you're a payment processor doing 1 in 5 every Australian payment. I'd encourage you to approach redesigning your code using railway-oriented programming and dry operation. It's going to massively simplify your code and make it much easier to draw the line between what Rails, the framework, is doing and what your application, what you're getting paid to do, is doing. You don't need to refactor out big chunks of your app at a time. You can build smaller operations and combine them as you go. And you'll see it works wonders for your applications. We've actually pulled out some of our own operation stuff and it's working really sweet. If you want to find more information about dry operation, it's over here on their GitHub and their documentation site. And that's all from me today. So thanks for having me talk. Questions, Simon. Oh, he's got a box.
Yes. You've sold me on the railway-oriented stuff, but is dry the only way to do it?
Nope. You can totally roll it yourself.
Cool. Okay, I'll keep that in mind.
What other questions are there? Come on. It's 20 minutes. Tom.
Hello, Ryan. So when you return those errors,
yes,
how do you translate those into UI-based things?
Yeah, so I'd use those case statements. So for particularly like on the authentication failure, I might want to return either just incorrect username or password, or in the case of the purchase thing, I might want to return something more complicated like that. We have one thing I kept out of the slides here is a bank response object. So if it does get down to the bank rails and it does fail in a particular way, it fails with a particular object that has decorated methods on it. So it's either like a success or failure. And then that bubbles up as a failure to the controller, and we can pattern match on the particular responses there if we wanted to.
Right. So translation happens at like the controller layer. You don't have the operations themselves.
Operations themselves don't do it. It's the controller layer. The thing talking to the operation handles the translation back to whatever needs to present that error. Might be a JSON endpoint, might be a view. Yeah, it depends on where it's used. Great question.
Hi. We use this pattern and we love it. It's good. The one thing we had a lot of trouble with more recently was using sorbet and dry monad, and yield syntax was playing havoc. Have you guys used sorbet in your code bases, and does dry operation help solve that problem?
We have used sorbet, but only in a code base that doesn't use dry operation at the same time. I want to, and I had the same problem in another code base of my own where sorbet was causing havoc and caused me to rip out sorbet. I wanted the monad stuff and I wanted sorbet, and I couldn't have my cake and eat it too. But
Yeah,
I'd love to try it out.
Step might fix that, but
yep,
find out.
I think so too. Yep, there was a question here as well. You have your hand up?
Does having not used dry operation, does every call need to result in a success or failure?
Yes, it does. Yes. You can have particular methods there. If you don't prefix them with a step, you can have them just be arbitrary method calls, but the step ones, I think, need a success and failure. I'd need to experiment some more, but yes. There's one over here too. Joff?
Yeah, detecting a bit of a theme here actually, because we do use that pattern as well in our code base, but more just the bare monads with the the yield syntax. So the step stuff looks nice. I guess the question is around engineers who forget that they need to return a success or failure and just leave the method returning nil or a string or some other thing. Are there things that you've used to help remind or help let people
sorbet
they need to return? Yeah, it's kind of where I was getting, raising errors instead.
No, we don't really have too much protection around that. It's more that those code paths, because variant payments have to be extensively tested. And when you're accidentally returning nil or a raw response object, that flares up quite quickly in the payment flow. So yeah, we catch it just based on the tests. We should catch it instead through some proper type checking. Yes.
Awesome.
One here, one there. I have 2 more slides after this as well. Me a bit greedy.
Okay, so I think you've kind of half answered this question, but a lot of what your examples rely on returning sort of success, failure, a particular structure to the responses. What are the actual benefits of having it like that over just arbitrary return types?
You mean returning either a success or a failure and then just returning symbols out of that? Or I'm sorry.
More like instead of returning a success or failure, return a string or an int or...
Yeah. I can use pattern matching on that. So I can wrap it around a particular failure case. And I might want to say this is a user that, a merchant that isn't enabled or with the authentication process works, but they aren't active or they've been disabled for a particular reason, and try and log that message, because stuff like that has been caught by support. So we have more complicated pattern matching around that. On the transaction stuff, we have those objects that I was talking about prior as well. I prefer using this because that has a good API that you can rely on, which is any result you get out of it, you can call .success, ? And .failure out of that as well, instead of just using the pattern matching stuff. And you can then handle different code paths on that if you really want to as well. I'm not sure if I really answered your question. I'm sorry. Okay. Yes.
Hi, Noob here. How do your tests look after adopting
I
this?
should have. I was thinking about that earlier today. I didn't actually find time to add it. I was like, there needs to be a test example here. One of the test examples that we have would be one that would call the call method at the top. And then each of those methods you can make private inside of that operation class if you want, and hide them all kind of underneath the water. But what I like doing for the more complicated versions of that is surfacing them as public methods, and then you can test just the public methods. So in that purchase transact code, for example, I might want to surface that find card by token method and then test only that part of the whole operation. And I can do that by calling the operation class, initializing that, and then calling find card by token and giving it whatever value I want. And I can only test that one tiny part of the operation without having to test the whole thing. And that's another benefit. If it's in a controller, I have to do whatever the before actions in the controller need me to do, and then get to the operation stuff. Where if it's out here in an operation, I can just go straight to the operation, straight to the method, and test it that way.
Follow up. Do you have to import any dry specific test helpers? Or
No.
No, nothing.
No,
Just-
nothing. It's all just regular Ruby after that.
I tend to lean into Ruby's exceptions as a way of passing around error information. And I work in quite a bit of code that has dry monads in it. And a pattern that I tend to see is the code deals with the happy path of a success object, and then it deals with the error, the failure path of a monad, and then it deals with exceptions as well. So we've just added another layer of control flow, and it gets really, really messy. Is that a viable way of working? Is there any hacks that we can do to simplify that?
I'd probably make the exception case handle like the failure case as well, and return failure in both cases. An expected exception is just a way that your code works. An unexpected exception should be logged by rollbar or whatever you're using as the exception monitor.
Goes all the way to the top.
Goes all the way to the top, bubbles up. That's right. But expected exceptions are something that your application knows about. That should definitely be a failure. And then your whatever's calling that needs to then be aware that it can fail in this particular mode later on.
Do you feel like that means that there's no space for anything but this monads pattern in the code base then?
No, there is. There's other ways of approaching it. You can't
but I mean, like, you can't have monads and something else. It's like monads or.
I'd prefer it just to be monads, just to make it consistent, because it's just what fits my brain the best. It's either it's all gone down the happy path and everything's fine, or it's a failure case. If you don't have this, I feel like it's a lawless wasteland. People invent their own ways of returning failures and successes and indicating otherwise. Some Ruby methods return a 1, where in certain languages that is a true value, and then the Ruby method might also return a 0, where in some other languages that's a false value, but in Ruby it's true. And we can't have that. There's a question back behind you.
It's kind of related to that. So I do a bunch of this similar stuff in Elixir. It's basically the same constructs.
Yes.
One of the things that sucks in that is trying to figure out where the error came from. And I'm wondering whether dry monad actually attaches any information to the errors so that you can figure out what's going on.
No, it doesn't attach the error. The dry operation gem does, so that you can subscribe to the failure event and at least log where that is happening.
Yep.
So the failure case, the bit you pass to failure gets passed to the on failure method, and then you can log that and maybe include a stack trace, or if it fails in a particularly known really bad way, you can what's the rollbar info, I think it is, and surface that up to like your exception monitoring system. If you have some cases that you're like, someone really shouldn't reach this code path, but if they do, we want to be notified about it. So yes, you can do that, and I think the pattern would apply in Elixir as well. There's nothing that Ruby does makes this possible. It's possible in any language. The railway-oriented pattern actually came out of F#, and
You can't just randomly get the stack trace in Elixir. I've tried.
No, absolutely. You can't, not in a compiled language. No way. But in Ruby, you could do a caller or a rollbar, or any sort of exception monitoring system worth their salt. When you do that rollbar info call, will give you whatever stack trace led up to that point. And then from there, it's probably got some parameter info attached as well. And you can use that to debug or diagnose whatever's going wrong. Question next to you, was there? No? Okay. All right. One at the front here too. And this will be the last one. And I've got 2 more slides. I'll be quick. The question is about the box.
Sure. Hi, thanks. My question is about this. I understand the monads should always, if something bad happens, go to the failure. But some of the services, third-party services especially, they could be flaky, right? Like,
no, not they could. They are. We talk to banks.
I mean banks as well, right? But I've seen in the bank codes, I've seen somewhere in the long history, like retries 3 times or 4 times.
Yes.
It feels like anti-pattern for that railway oriented. Is that right?
Well, you could have it fail in a particular way. So it might rescue an exception, or it might see a particular HTTP status code and raise that up as a failure from within the operation. The code wrapping that operation then can see that failure, that particular failure, and say, retry again, and just go through the whole stack again. That code doesn't have to be in the operation to retry. The operation is attempt this thing, and the thing that doing the retrying is the wrapper around that on the outside, I think.
Makes sense. Thanks.
Yep. All right, cool. 2 more slides.
All right, thank you.